For today's lesson, you're going to be solving for a missing angle in a triangle. So we've already done solving for a missing side. Today we're going to solve for a missing angle. Alright, so what I'm going to do is just step through a couple of examples and then set up the mechanics of how we do it, and then I'm going to make sure I do some on the calculator so you can see how to actually put that in your calculator. So let's start with this triangle. Alright, so I've got sides of 31 and 44. The angle I want to find is marked X. That is my right angle. Okay, so in relationship to this angle, that's the opposite and adjacent sides. Since I'm working with the opposite and adjacent sides, I need to use the tangent function. So what I'm going to say is tan X equals 31 over 44. Now, in a lot of ways, solving for a missing angle is even easier than solving for a missing side because it's just going to require one step. Now, what that step is that we need to get rid of, we want to get x by itself, so we need to get rid of the tangent. Okay? So we need to like make that tangent go away. Now, if this was like 2x, we would just divide by 2. So we need to do the opposite of tangent to both sides of this equation. On your calculator, if you hit the shift button or if you look above the tangent function, you'll see this button, tan to the negative 1. That's called the inverse tan function. The inverse tan function is what undoes the tangent function. So what I'm going to do is do that to both sides of this function. So inverse tan of tangent of x is equal to inverse tan of 31 over 44. Now, inverse tan and tan just cancel each other out and leaves me with x. Okay, so x is going to equal inverse tangent of 31 over 44. All right, how do I put that in the calculator? Well, if I have a calculator like this, I can hit my shift button and then tan, and you can see how that tan to the negative 1 comes up. And give me a second, I got to switch this to degrees. There we go. So inverse tan, and now I just want to put in that fraction. On this calculator, I can just put it in as a fraction. So I can put in 31 over 44. Whoops. Okay, and it spits out for me 35.166 degrees. Now, whatever assignment I have is going to tell me how accurate I have to be. I think the one you're doing today is just to the nearest degree. So this would be 35 degrees if I'm going to the nearest degree. If this was to the nearest tenth, I would say 35.2 degrees. Okay? But once it's like this, just know inverse tan of that fraction. On another calculator, let me show you how to do it on a less scientific calculator. So like, for example, if you have a phone, right, to do that one, remember on this kind of calculator, you have to put the number in before you hit the tangent button. So what I would have to do is do 31 divided by 44, figure out what that is as a decimal, and then if I hit my second button, you'll see my inverse functions come up along here. And so then I hit inverse tan, and it says 35.166, same thing we got on the other calculator. So again, that's 35 degrees if I went to the nearest degree. Okay, let me just step through one more example, just so we have another example to look at. All right, let's do this one. Say we're looking for this angle, and the sides I have are this side, which are 18, and this one, which is 14. Okay, in that right triangle, in relationship to my angle x, this is the adjacent side, and 18 is the hypotenuse. So the function that uses adjacent and hypotenuse is cosine. So cosine of x equals 14 over 18. Now to get rid of cosine, I need to do inverse cosine to both sides. So x is just going to equal inverse cosine of 14 over 18. Okay, and then putting in my calculator, inverse cosine of 14 over 18. Excuse me. And that one to the nearest degrees is 39 degrees. So in this case, x would equal 39 degrees. Okay. So there are two examples. You can certainly look for videos of people solving for angles if you still want to look for some more examples. You have about 26 problems on your assignment. Once you get going on them, they're actually really quick. I will see you guys on Tuesday.